Okay, so thank you so much for joining the session. For the sake of everyone to know, my name is Aftab Siddiqui. I work for Internet Society and being part of the project called Manners, Mutually Agreed Norm for Routing Security. And with me, I have my guest, Geoff Huston from APNIC, who's the chief scientist, and someone who has taught us a lot about BGP, well, about DNS and everything else, but mostly about the BGP and how insecure it has been for many years. So let's talk about something more interesting about the history of the routing security, not just the BGP. Let's say go back in time and ask about a little bit more. So welcome on board, Geoff.
Thank you. It's a pleasure to be here.
Okay, thank you so much for that. Right, so first question I have for you is the SIDR, the Cider working group, started in 2006. Before that working group at IETF, where were the BGP security related or the routing security related questions were discussed?
Okay, so, in some ways, I've actually got to peel that back a little bit further and talk about the way the internet wanted to route. And I'm actually heading into the DARPA-sponsored work, which is the very early days of the internet. At the time, the mode for networks was directed routing. And so if you looked inside a telephone network, you'd actually have configurations which were manually applied, and the networks didn't self-heal. Now, there was very early work done. RAND sponsored a lot of that work in the late 50s in early computer networks, which talked about self-discovery and self-healing. And the way this worked was there were no preset configuration files, one way in, one way out, one fixed topology. The dream was in the 1950s that we could devise computer networks that understood topologies, learned them and adapted, a bit like driving to work, which in this COVID blighted time, some of you might remember driving to work. I don't think I'd do anymore. If your primary road's blocked, you take another road. You don't just sort of cancel everything and go back home for the day. And we wanted computer networks to display the same thing. So a lot of work was put into self-learning protocols. And two researchers, Bellman and Ford, came up with an early one, which we now call Bellman-Ford distance vector. And there are a number of other folk that did contributions on that. But they all shared one thing in common, that in that self-learning network, nobody lied. We all trusted each other because that's the way self-learning networks work. I tell you everything you know, you tell me everything you know, we believe each other. And it wasn't until Radia Perlman in 1988, I think she was working for Digital at the time, and some of you might have seen some of Radia's books. Interconnections is still a masterpiece. Shameless plug. But she talked about what we called the Byzantine general problem, where what do you do if one of the players isn't trustworthy? How can you survive that? Now, her work was in the area of what we call intra-domain protocols, inside a network where one of your routers has gone rogue. But it's the same kind of problem in the larger internet. What happens when someone's a rogue player? Now, we went through a number of routing protocols, Hello, the gateway protocol. There are various versions of GPs, EGP. There was one based on timers, which was bizarre. But at the time of DARPA, everyone was on the same side. And so security wasn't an issue. But by about 1990, 1991, when the academic and research networks of the world were becoming more open, the routing issues became prevalent. Now, the first piece of work was actually the Internet Routing Registry work. And it was paralleled by both the NSF in America, the National Science Foundation, that funded Merit to work on what they called the Routing Arbiter Database. And at the same time, the RIPE NCC, only 4 people at the time, who was it? Tony Bates, Martin Terpstra, Miriam Kuna, and Daniel. But they started working on this idea of a registry of routing, similar to the routing arbiter system. And those two parallel efforts kind of started this idea that I can't change the protocol, that's okay. But what I can do is describe what you're going to do, and I'll describe what I do. And if something on the wire happens that you didn't say you were going to do, and I didn't say I was going to do, it's probably wrong. And so a fair deal of work was actually put into the Internet Route Registry system. And that extended through a lot of the 90s in trying to sort of do this as a commentary. The IETF took hold of it. They developed a language, the Routing Policy Specification Language, RPSL, that nobody understood. And it became fashionable for everyone to run their own routing registries. Oops. And by the end of this, early 2000s, we had about 30 route registries, and they were mutually inconsistent. There was material dating back from the early 90s. There was material put in yesterday. No one knew what was right, and there was no authority model. I could enter data about your nets. You could enter data about my nets. Oops. And so that triggered a discussion about what can we do better. And from that came a whole bunch of proposals which were circled around. So I'm still doing the history here. And there were a number of proposals that started to take form. And the one that I think coalesced the most was actually work done by BBN called SBGP. And this applied a relatively rigorous model of protocol correctness and actually tried to make sure that we could add signatures to BGP updates. Now, it parallels the work in DNS, where we're adding digital signatures to DNS answers. Is this the real answer or someone lying? That was the spirit of SBGP. Is this a real update or is somebody lying? The digital signature should be able to say authentic, can't deny it, really happened, and it's not someone tampering. The problem, I suppose, was that when the vendors, because BBN was not a hardware vendor at the time, looked at this, they kind of had a quiet vomiting fit out the back, because it might come as a surprise to you, but the processing power in a router, it would make even 8080s look pretty grunty. People did not build honking great supercomputers to shift packets. All the intelligence was out in the line cards. The CPU was sort of, a woeful excuse. And so when you're trying to do a massive crypto load in a router, the answer is meltdown. And so within a few years, Brian Weiss and Russ White came to the IETF with something that they thought Cisco could build. They were both working for Cisco at the time. And this was the thing called SOBGP, Secure Origin BGP. And the major difference was it sort of weakened the crypto, right? And what was going on there was, I'm not trying to do a rigorous test on the protocol, but quite frankly, if you lie, you've either got to lie such that it looks like a real update, who cares, or it's detectable. Okay, fair enough. We got very confused. One group saying SBGP is the answer, another group saying can't build it, want to build something a bit different. And so the IETF in management mode stepped in, and quite frankly, a bunch of IETF standards folk trying to do management is always a bit of a joke. And this one kind of reinforces that attitude. And the end was, let's back off. Route registries aren't working very well. We don't really have a clear idea of how to make the protocol work. We've got these two competing protocols going on. Let's go back to basics. What are the requirements? And so the first thing they did was start up what we called RPSEC in the end. The requirements for security and routing, trying to generalize the problem, right? And that erstwhile working group worked diligently for some years and found themselves pretty clear about what origination was. If I want to originate a route into the network, I need to have the permission of the address holder, because if I don't, I'm hijacking. So if I want to originate your address, you need to say yes. Now, most of the time, they're the same person. So the right hand says yes to the left hand. Great. But at times, they're different. And at that time, I explicitly need that permission. Everyone agreed. Good, let's move on. Let's talk about propagation. And at that point, the world fell apart. Because while SBGP said the path that an update propagates through the network is accurately reflected in the AS path, another camp said that's rubbish. Because people lie in AS paths. We use AS path poisoning, not no time or rarely, but we do use it because sometimes it's useful. The whole thing about AS path prepending. What do we do with route reflectors and exchange points? You know, so there's a certain amount of the AS path is merely an approximation of the path of the update. And the RPSEC folk could never quite agree whether the path was an exact record of recent history or merely an approximation. Everyone was sick and tired of waiting. And so the ISG, again in management mode, reference previous comment, said, right, let's just start up a working group for Cider. And there are a couple of rules. You can only work on stuff RPSEC has agreed on. So when you start, you can only work on secure origination. Path is a future problem, rule number one. Rule number two, which I think was one of the most astonishing errors ever made, you can't alter BGP. Cannot. You can't bring in a new message type. You can't even make a new negotiated attribute. You cannot alter BGP. It's sort of, okay, those are the ground rules. Let's move on. And so that's how Cider came up. So part of it was a relatively rich history, but a relatively rich history of what turned out to be competing proposals, but that turned out to be competing concepts of what was trying to happen. Don't forget, SBGP can't detect route leaks. It doesn't enforce policy. It's just protocol correctness. So even in the final analysis, all that work didn't get you everything. It got you some things. SOBGP wasn't as strict, and so it didn't even do a fantastic job on all possible cases of lying, and also wasn't very good at policy either. But, you know, it was kind of, well, it restricts the liars to a point where lying doesn't matter. What's enough was the real question. So that's how Cider came into being.
Okay, that's really good. I mean, I was not aware of the RPSEC background, so now it makes a lot more clear now. Yeah. But I was looking at the notes of the SIDR, the Cider working group, and the very first BOF, which you hosted, there were 3 versions of the BGP on the table. 2 you already mentioned, SOBGP, SBGP, and the third one, which I had no idea about, was PSBGP. Pretty
secure BGP. So, okay, both SBGP and SOBGP had a problem. And the problem was, how do you inject trust? That's my address. Well, yeah, great, Geoff, but who said so? Well, I did. Well, why should I believe you, Geoff? You're a lying, you're a lying bastard. You're from Australia. No one believes you. And that's true. Assertion is not truth. It's just an assertion. And SOBGP and SBGP both kind of waffled the idea of where does authenticity come from. Now, in the DNS, it's easy. Example.com only exists because com lets example exist. And com only exists because the root zone lets com exist. So the domain name actually defines your authority, right? Everything comes from the root. But an address, there's no such structure within the address. In V4 with 4 octets, the first octet doesn't mean any more or less than the second or the third. It's not a chained hierarchy. And so the question really is, where does it come from? And SOBGP and PSBGP were kind of faking it. And in the same way that there are a number of proposals for PKIs that didn't use a hierarchy. Phil Zimmerman's pretty good BGP. Sorry, not BGP, pretty good security. What was it called? Pretty PGS or something? Phil Zimmerman, great piece of work. Yes. But it relied on the wisdom of crowds. If everyone says that's your key, that's your key. right? Simple as that. And so PSBGP was actually about, well, if everyone else says it's Geoff's address, good enough for us, it's Geoff's address. And so PSBGP tried to create trust based on statistical metrics. If enough folks say yes and few folks say no, the ayes have it. If everyone's screaming no, it's not your address. And that was the kind of model of the fight, or if you will, why there were three competing proposals. SOBGP and SBGP didn't really talk about the structure behind these certificates. PSBGP tried to fake it out. But prior to that work and independently, and I've got to stress this, independently, I was in a group in APNIC and we were working on a completely different problem. The problem was that our registry was just a collection of ASCII lies. When you do a who is query, how do you know the answer's authentic? I went to the right address. I went to the right who is server. No, same question. The fact that you went to somewhere that you thought was the right place doesn't mean the answer you get is the right answer. It just doesn't. You may not have gone to the right place, and even then, someone might have been playing with the data. How do I know that the data I retrieve is the data that you put in to describe yourself? How can I trust the registry? And we've been talking about that for over a decade, because we're all, and still are, pretty disgusted with who is. It's, like I said, just a bunch of ASCII lies. And so we were trying to create a signature structure that said, a bit like DNSSEC in the same model, if we can put signatures inside that data, then we can say, we, APNIC, we, Aaron, we, RIPE NCC, gave you that address. We did an allocation assignment. Give us your public key, and we will, with our private key, sign an attestation saying AFTAB 192.0.2.0/24 is yours, and here's your public key. So I don't care about your name. I really don't, sorry. I care about the fact that you own something, a private key, that I'm associating with that address. Bingo. Because no one else can, if you will, make that attestation anymore, because they don't know your private key. And we were the registry. So we only gave that certificate out for one party. And that's the basis of the RPKI. It had nothing to do with routing. It had a lot to do with registry, right?
So it brings me to the second question on the same point is, so the draft you suggested, the very first draft for the SIDR working group was proposed by you, George Michelson, and Robert from APNIC. So all three of you proposed this exact same thing, that the X.509 should be used for this purpose.
Well, we were working on a PKI inside APNIC, and it's pretty clear, as anyone who works in technology, you can dream up all kinds of good ideas, but to get everyone else to use them, you actually need an agreed upon standard specification. So we'd waded through all the various X.509 profiles, and there are a lot. And we'd, if you will, taught ourselves X.509 for beginners. And we're trying to understand all the fields in an X.509 certificate, and there are a lot. Which ones were useful, which ones were dross, and how could we build a special purpose PKI? Now, most PKIs say identity. I'm Geoff, and someone's agreed that I'm Geoff. So the certificate is all about my identity. Or it could be my role. I work at APNIC, I'm worker B number 20, and APNIC certifies I'm worker B number 20. And oddly enough, that even might open doors, right? Similarly, inside the credit card system, I'm the holder of a credit card. What we wanted was, if you will, a bearer certificate that said whoever owns the private key, don't care who they are, don't care about anything else, but the owner of that private key is associated with this resource. And that was it. Now, we'd gone a fair way, but it wasn't a standard. And if anyone's gone close to the security working groups of the IETF, when I say they're scary, you'll agree with me. You know, they speak a different language. God knows what the language is. They're relatively rigorous in a very severe way. And we, I must admit, in our endless, boundless optimism, thought we could slide through a PKI about about addresses and AS numbers through the routing area as, you know, PKI light, which kind of worked. It became an RFC, and it did get some attention from the security working group. In retrospect, I think we kind of stupidly dodged an inevitable, you know, process. We should have gone through the security working group, but water under the bridge. But that's why we worked on it. Someone had to do it, because otherwise you couldn't build the rest of the superstructure. So that was the reason why it went through Cider. It was just a convenient place.
So is it safe to say that you and GGM, because Robert is not an APNIC anymore, so you two are the responsible person putting X.509 in the RPKI?
Well, PKIs are X.509,
yes.
right?
Yes.
That's just the nature of what is a PKI. It's a hierarchy of certificates. We looked very hard at the emerging DNSSEC, and we had watched the massive saga of DNSSEC that started with X.509 certificates, and in the end went away from that and went to what I would call naked keys. And we were keen to understand whether the burden of X.509, and it is a burden, it's a huge amount of cruft there, was worth the effort. And was it possible to slide this through either by cloning DNSSEC and actually doing it in the DNS, or doing it with naked keys? You know, just get rid of all the rest of this, you know, ASN1 nonsense and just have the key. But we couldn't make that work. We actually had to go X.509 to do what we needed to do.
Oh, okay, that's perfect. So just moving on to that. So then, as you said, it became an RFC 6487. It took a lot of years to convince everyone at the Cider working group to make that an RFC. So
that one wasn't the fight. That was just a bunch of selections, and in some ways there was no particular hurry, and so it wasn't sort of pushed through in a mad rush. What the profile says is, you know, it's a bit like going into a restaurant and seeing a massive menu. In X.509 world, there's a huge amount of stuff you can pick. And what you need to do is to say, in a compliance certificate, you should never use these options. They just should never appear. And if you try and use them, that's not a valid certificate. Throw them all out. There's another set of options that must be there. And if you don't use it, that's an invalid certificate. Throw them out. And there's another set of options that might be there. You can use them or not as you feel, but you can only use them in certain ways. And those are the sets of choices that profile was making. Now, this was prior work. George and I had talked to folk and, as I said, got ourselves up to speed and started doing proto code, scripting OpenSSL to get the hang of that. And oddly enough, the first task we did was to take the extension to certificates that allows you to talk about IP numbers and AS numbers, which we all quote as RFC 3779, which is a little extension to X.509 that says, I can stuff numbers into a cert. And we were looking hard to try and find an implementation. And that was sort of the first task, to actually make the registry system work. It had nothing to do with routing per se.
Okay, so as you said, there was no hurry at that time.
Didn't seem like it.
Yeah, and I mean, in a typical Australian politician type of way, say, well, it's not a race. Do you think the 2008 PTCL YouTube hijack incident created it as a race, or it was just a wake-up call for few people that you have to dig deep into this? No?
No.
Okay.
The defining moment was actually your friend and mine, the US Department of Homeland Security.
Okay.
The US Department of Homeland Security correctly identified a long, long time ago that cybersecurity was the battlefront. And they also, I think, quite correctly identified that our digital infrastructure is, well, woeful is a generous way of saying it. You know, and those who think everything's fine are either dead or they just don't understand the true extent of this problem. And today it's ransomware. Last week it was shutting down a major oil pipeline. This is horrible, right? And Homeland Security not only was saying, well, it's horrible, but the real question is, what can we do about it? And so they had a very interesting way of doing things. And the PI, the principal investigator in Homeland Security, Doug Bourne, came up with the relatively neat mode of operation that if you really want to move things along, fund the research. Well, that's pretty typical. DARPA, internet, fund the research. Fund the standards. Fund folk to go there and push the standard. Fund the implementations. Send money to Cisco. God, they needed money. Not. And June, fund implementations, fund the vendors, and fund operators. Now, that impetus, particularly in the US in the context of DHS, created a sense of urgency because the money wasn't forever. And it actually got a whole bunch of folk who otherwise would have gone, well, research is driven by money. There's no money here. I'm not going to do anything. All of a sudden got everyone's attention. In the same way that I think DNSSEC only got solved with a little bit of a kick in the pants from DHS, to be brutally honest. This was the same kind of impetus. So it wasn't an external reaction. It was actually the US pushing through DHS to say, look, let's get serious. Let's just do this. And that created a much bigger sense of urgency than anything else, because it was pretty clear the money was a fixed amount of money over time. It wasn't going to last for even 5 years. Answers needed to happen immediately.
Okay,
YouTube is just a convenient excuse. I'm like, yeah.
Okay. So we can put that argument to rest, at least that
Totally.
they were not the only reason.
No, well, they weren't even a reason.
Okay. I hope anyone from PTCL listening to this conversation will be quite happy with this statement.
Well, no, but seriously, and it also explains why the urgency has dropped off again. Cider Ops is actually doing nothing. They're just tinkering at the edges. And the only decent work there, ASPA, is just sitting in the doldrums for 3 years. And the answer was, well, no one really cares because there's no money to bring attention to the problem. And without attention, no one cares.
So that brings me, you mentioned Cider Ops, right? So
Yep.
Cider has been concluded, right? So they said, well, we have done our job. We gave you RPKI and a bunch of other things. Which
no, hang on. Cider was concluded because the fight was intractably bad. And there was kind of two elements of the fight, if you will, and neither had an easy resolution. The first was a difference of opinion in the PKI itself. And that difference of opinion, I'd actually put all the way through to geopolitics. And it was certainly deep. In the DNS, there is one key. There is one algorithm. And that algorithm is actually RSA. Now, if you go and talk to someone who doesn't live in America, who works in cryptography, they might well put forward the case that RSA has been cracked and that they believe this is a deliberate ploy by one group of national interests to promote a pseudo-security model using compromised algorithms. And they should have used some other algorithm which was so much better, right? One key, one algorithm, other countries regard as fundamentally a bad idea. And so when we came to the RPKI, that argument, which was lost in DNSSEC, one key, could be replayed. And the whole idea that one key held by the IANA, one algorithm, did not strike global favor. And indeed, it was viewed with some suspicion that the same US interests were promoting a compromised algorithm. Now, was it compromised? No one says anything. No one knows. Or if they do, they're not allowed to say. And I do not know, right? I'm not a crypto person. But part of the issue was that was a fight about one trust anchor or many, diverse keys or one, diverse algorithms or one. And that was never going to get resolved in the IETF. It's way above everyone's pay scale. And the ambiguity was helpful for some interests, okay? The second issue was the rush to push forward AS path validation. And in essence, what happened was the protocol that didn't work last time, SBGP, was reproduced with a PKI and called BGPSEC. Now, it didn't work the first time, and there's no reason to think it's going to work the second time, but DHS was on, an urgent mission, right? And because they were on a mission, the stuff was just railroaded through. It was as bad as the original implementation and equally unimplementable, or at least undeployable. You could implement it, but the deployment considerations were intractably bad. Now, Cider was then faced with the decision as a working group to start a competing standard, SOBGP again, and replay the same fight from 2003 and get nowhere, or call it quits, move away and run to the hills. And option B was chosen. Why? Because no one wanted to replay the fight and work through those interminable issues. Should we standardize something that never gets deployed and call ourselves heroes for doing a job badly? Or should we pragmatically come out with a job that works? And we couldn't resolve that question. And because we couldn't work on anything else. We just stopped. Now, the excuse was, we'll set up a working group to look at the operations of Cider, and we'll come back and reconvene when everyone's drawn a few breaths, calm down, and we'll attack the protocol work a second time around. In reality, Cider Ops has actually been RPKI Ops, and there has actually been no route origin validation ops to any great extent, which is kind of a pity, because the application of RPKI to BGP was, again, a fundamentally flawed design decision.
Okay, so let me just go one
step at a time,
half a step back, right? And ask you one thing. So you mentioned that DHS did a great job in terms of funding the whole research and the standard, and researchers plus vendors and then operators. Everybody
got funded.
Yes.
In the US. In the US.
Well, that's a pity.
And a couple of others.
But what happened with the BGPSEC? They did fund the standard, they did fund the research, so they didn't fund the operator and the vendors?
Well, the problem was, you might recall the other big sneeze that BGP had to do was 4-byte ASs, changing from 16-bit to 32-bit AS numbers. And then we had to change BGP, right? But the problem was you couldn't change all of BGP at once. And so we had to create islands of capability and then reach across the sea of ignorance to someone else who was capable of running 32-bit ASs. So we had to kind of do this piecemeal adoption where you could bridge across the bits that didn't do it, right? But when you're talking about AS path validation, I sign the originating AS, I sign the next hop AS, but my neighbor doesn't talk. Oh, well, let's just drop all the signatures. All the signatures. So even if that AS, or so that update propagates to someone who is then BGPSEC aware, there's nothing left. So these islands can't bridge across a sea of ignorance. So the only way BGPSEC could have ever been deployed was to build outwards from a mythical middle. So no one could make an independent decision to deploy, because you can't. And even coalitions could only protect within the coalition. The great sea of ignorance was as bad as ever and couldn't be protected. So here was a huge amount of work. You had to put private keys on routers. Anyone who runs routers would be sitting, coughing and screaming at that particular sentence. It's a really tough thing to do. You had to get routers to sign things. Yay, there's so much crypto capability, because I think we've only upgraded the processors in routers by, a couple of cycles per second. They're still not supercomputers. So they had to do a lot of work. You know, you needed to put a lot more security on the router, and you couldn't even get any protection because you had to actually make everyone do it. That is a recipe for never going to happen.
So if I can rephrase what Martin Levy said a couple of years ago, that, and he emphasized it many times, never, ever, never, ever BGPSEC will be deployed, something like that.
Oh, that's what I'm saying. I'm like, it was dead. It was dead even before they started working on it, because SBGP was dead, and SBGP had all those failings. And so BGPSEC was developed in deliberate ignoring of the lesson there, simply because DHS was impatient. And now, sometimes you can get designers and engineers, when I was certainly in the design crew, you can crack the whip on me and make me work harder. But sometimes when you make me work faster, I just produce rubbish. And when I say I and me, I'm talking of a lot of my peers as well, because some of these problems are difficult and you need to think about it, and that takes time. But if you've got to produce something by next week, you just push something out the door. And that's what happened. And in that case, the money kind of did the wrong thing. It produced an urgency that actually repeated a mistake that we knew was a mistake. And Martin was right. And BGPSEC's never going to work. It's dead.
So if so Cider's Cider working group did two things: worked on the origin and the path validation. Origin was a success, but path validation wasn't.
Well, Origin was successful because it didn't change BGP. It was all external. I would actually argue it's actually an abysmal failure, but we can get into that later as to why. And it's about the distribution. It's not about the technology, but the way we distribute those credentials is actually completely inverted and wrong. So that bit worked. The bit on AS path, as I said, was a piece of desperation to sort of tick a box for DHS. And that was just never going to happen, right? We couldn't make that work. And so out came a standard, but that's all it was. It was just a standard. It was just an RFC.
Okay. So path validation, we have to move on, right?
Yeah, move on.
Okay. Now, going back to your initial point, the origin validation. So what is wrong with it in the current scenario?
Okay. See, BGP is odd, and it's unlike any other conventional security mechanism. You and I are talking on a secure session. We're actually validating a domain name, zoom.us or whatever it might be, right? Now, there are hundreds of millions of certificates out there and hundreds of millions of domain names that could possibly be validated, but you and I don't care. To set up this session, I got handed a small set of certificates that I checked against my trust anchor and thought, oh, these look pretty hunky. I'm talking to the party I'm meant to talk to. Yay. So every transaction only brings up a microcosm of the PKI world, just enough to do the job. Routing is different because my BGP speaker sees every route. So does yours, in theory. So does everyone's, in theory. And that means the entire set of signed objects need to be brought to bear to each speaker. Now, in the PKI world, we've never done that before. And everything, I think, we dropped a few lessons that we should have learned. And one of the lessons is, when you've got a publication and distribution problem, if you make publication easy and put all the work on the clients to get the data, you've got it backwards. The early models of web publication disappeared with CDNs. Why? Because it was easy to publish, but being a client was not just slow. I'm like, you died before some web pages came in, right? I don't know if you remember how slow it really was. And it wasn't that the network had no capacity. It's just physically, it's a big world and the speed of light's only so fast, right? And so the way we faked that out was actually making publication more involved. It did more work. And the whole idea was to get all the content close to the client making the client's job incredibly easy, right? Now, in the RPKI model, the publisher publishes in a local repository. Easy. The client has to check every repository. But the publisher actually doesn't know who the clients are. So when the publisher changes something, no client is aware of that change until they come and look. So now the client's got an even harder job. They have to check every single repository all of the time just to see if the publisher's changed something. I'm like, you couldn't make the client's job harder. Now you think, oh, that's easy. And if it's just you and I, AFTAB, it's easy. If it's just 30 publishers and 30 clients, now we have computers to do that. But don't forget, there are 100,000 active ASs out there. And in the RPKI model, in theory, everyone's also a publisher. That's 100,000 publishers and 100,000 clients. How often do the clients have to check all the publishers? Right? That's 100,000 squared every second. Every second. We can't do this. You know, somehow we kind of assume, oh, we've got computers and networks, this is easy. It wasn't easy for the web, and it's not easy for this. And so the whole idea of you can't touch BGP, but you have to distribute credentials not using BGP was the bit that we broke. There's actually only, I think there's only one reliable flooding protocol for the internet we've ever actually built. And oddly enough, that flooding protocol is BGP. And if you want to actually flood information, as lots of folk found with their AFIs and SAFIs, the best way of doing it is to make it a BGP payload and just do it in BGP because it floods reliably. And so staring at us in the face was the answer that if you really want to put RPKI credentials around the net, you know, all those signed products, use BGP. But no, we invent, you know, we attached our boat to rsync. As it turned out, rsync is a disastrous protocol, completely insecure and incredibly inefficient. So then we started tinkering with distribution protocols. We've now come up with RRDP. Is it as good as BGP? No. Can it be as good as BGP? No, it can't. What's the problem? Clients don't know when publishers change things. A pull protocol is wrong. You've got to push. And if you don't know who your clients are, you've got to push flood. You've got to assume everyone's a client and push flood. Who does push flooding? BGP. So if you really wanted this to work, you would make this a message type. Did we know that? Yes. Go back and look at SOBGP and how did they distribute their certs? In a security message type. Again, we just ignored this work. And somehow we had this sort of massive bout of amnesia. SOBGP was wrong. Everything SBGP did was right. SOBGP used a different BGP message type to flood credentials. Therefore, it's wrong. And it's kind of, no, it doesn't. It was actually an inspired good idea that we just forgot about. That's been the problem.
So RPKI has a scaling problem.
Because a client pool model can't scale.
So, but that is relevant if, in theory, all 100,000 networks start pulling the data from the trust anchors.
That's the only tool they have. All the clients have to pull. The only way we can even think about trying to make this scale is to reduce the number of publishers. And the RIRs have almost done that. So this sort of aggregated publication models, the issue is though that each CA separately publishes. So even though there might be a bunch of publication points behind one IP address, it's still a bunch of publication points. And the fundamental weakness is, you know, you don't know when things have changed. So you go, okay, so let's try and produce intermediaries, aggregators, the equivalent of CDNs. Now, remember what I said, that BGP needs all the information. And if you haven't got all, that's a problem. So I use an aggregator. How can the aggregator assure me, the client, that they're faithfully representing the entirety of RPKI information, a global manifest? And the answer is, you can't. It doesn't exist. And so no matter which way you look at this, we can't make this pig fly. It's a pig. It doesn't have an airfoil. It doesn't have feathers. It can't fly. You can put thrust on it and it'll bounce off the ground a bit, but ultimately it's the wrong model. The model needs to be a model where the publisher needs to flood push. And the answer is you can't flood push. BGP does it, standing on its head. So we know how to do it. We just, for some reason, got constrained. That early decision about cider design, don't touch BGP, created this fundamental problem. And whoever was the routing AD at the time, I'll leave their names fogged in history, just simply, I think, did us all a massive disfavor 20 years later or whatever, 10 years later, because trying to make that fly without being able to alter BGP left us hamstrung, talking about basically jury-rigged solutions that we just can't make work.
Okay, so so what is the solution right now, without saying it's a gloom and doom?
No, I'm not saying gloom and doom, but I am saying it's an unfinished story. I actually don't think we've come up with a better model than the RPKI as a PKI. You could argue a bit about trust anchors, but you've got to be aware of the geopolitics about crypto. This way is a compromise. It's not the best answer. On the other hand, there's not one key that's critical. There's a bunch of keys that are critical. And in theory, they have the ability to use different algorithms. Fine, move along. I don't think there's many better ideas there. But the other parts of this, we actually need to contemplate the fact that we need to think about this a little more. And one way of looking at this is that recent work done that actually allowed BGP attributes to be up to 65K in size. Because now we can actually use BGP to flood certificates, CRLs, and even manifests. And because BGP is a TCP protocol, I know everyone gets it. And they get it, oddly enough, inside of the time to propagate a BGP message. And if you think about, well, how fast does it need for credentials to follow an update? The answer is as fast as BGP. Any faster is overkill, any slower is a pain. How fast can BGP run? As fast as BGP runs. If you use BGP, you can get away with this. Is that a change? Well, no, it's the same credentials, it's the same PKI, but you're getting it to the client in band rather than inventing a whole new distribution mechanism that simply is, it's got failure written all over it, despite our best efforts. So the first thing is we're not throwing that bit out. Maybe RRDP is never going to fly, but it's, like I said, solving the wrong problem. So then it's a case of, does origin validation kind of work? Well, the shared filter list is an interesting idea, right? It is an interesting idea. Offloading the crypto using a filter list versus using an iBGP feed of poison routes. You could do it either way. So what you're trying to do is take all the crypto processing and drop it in a dedicated engine that has all your network's routers fueling themselves from that engine. So they don't have to do the crypto. You one or two machines, if you're interested in redundancy, can do all the crypto processing and reverse feed the bits you shouldn't be accepting. The shared filter list was interesting. If you really wanted to do this minimally, you would have done it in iBGP, same answer. AS path was the tough bit. And like I said, I think SOBGP is there for a good reason, because in some ways, not solving policy and being way too strict on AS path as, if you will, the only way of doing this is crazy, just absolutely crazy. How often does topology change? 30 new ASs a day? That's not a lot. Over 100,000 component networks in the internet, the relationships that were there yesterday are much the same as the ones today. Topology doesn't change. And so in some ways, if you manage to look at path in the way that SOBGP did, and look at it as a bunch of paired wide adjacencies and reliable flooding, you've suddenly got a really tractable problem that's lightweight. Now, I think the work in ASPA, AS path, path provider associations, is actually a nice piece of work. It builds on SOBGP with one critical thing that was missing. Who's my providers? Because route leaks are actually leaks about the logic that customers should never re-announce routes learned from provider A to provider B. In the parlance of interdomain routing, it's a valley route. If you regard customer, provider, 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 customer, 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 then you go up a mountain and down a mountain, right? All paths have that property. If there's a valley, it actually means the customer has learned it from somebody and then re-announcing it to another provider. Bad idea. Now, ASPA encapsulates that in pair-wide attestations. And it basically says providers don't need to disclose who their customers are. Fine. Customers disclose who their providers are. Now, we knew who their providers were anyway. It's called BGP. So you're not actually exposing information that wasn't already there. You're just confirming it. Why should I confirm it? To stop people lying about me. So it doesn't solve everyone's problem. But if I publish my ASPAs, my attestations about who my providers are, if nasty person over there somewhere tries to lie about me, they also have to lie about the fact that, my provider, because they've got to include them. And if they list their providers and so on and so forth. So what happens is the path of potential lies gets so constrained that it's very difficult to fake a path. Secondly, if I leak a route, it's immediately obvious that I am going against that flow. I've learned a route from one provider. I'm re-announcing it to another. Geoff, you've just hung yourself. But the beauty of this one is everyone can identify that as a route leak from the point at which it happens. And so if my neighbor is doing ASPA validation, the immediate announcement to that provider saying, I learned this from another provider and I'm your customer. And the answer is, well, that's really dumb, Geoff. I'm not going to propagate. I'm not even going to learn this nonsense. Back in your hole, stop that. And so I think that's a really nice piece of work. But why isn't it coming out as a standard? Well, Cider Ops is the big clue. It's not a protocol development working group. It's not part of the routing area. It's part of operations. And, ops working groups should not do protocol development. And I think there's a certain hang up. And the other thing is everyone's having so much fun trying to make the pig fly over RRDP, trying to make a pool-based constant polling distribution model work, that ASPA has just got lost in the weeds.
So just to summarize the last point, and moving towards the closure, is we have two issues in hand. Number one is the distribution issue with the RPKI origin validation. It has a scaling issue. And the second, for the path validation, we don't have a clear solution. There is one, which is ASPA, but it is just in the draft phase for
there's no
quite
momentum.
a long time.
There's no momentum to solve it. There's no momentum to get it out into product. There's no momentum to adopt it. And part of the reason is the last time we gathered momentum, it was because DHS paid us to all give it attention. There's no more DHS anymore. No one's paying. And because no one's paying, sadly, no one cares.
I hope Doug is listening to this conversation and can get some.
Unfortunately, Doug moved on with his career. But it is a very valid point that this industry, solves immediate problems well, but common problems badly. And I think that was the reason why DHS stepped in the first place. Common infrastructure, it's hard for individual players to get motivated to help everybody else. Why should I spend my coin helping you? Becomes the common problem of everyone. And these kinds of good ideas tend to lapse when it just doesn't seem to gather attention and motivation. So it's a good idea. There's nothing wrong with it as far as I can see. And it merits publication as an RFC. It merits vendor code. It merits support, right? Operators should be looking at this and actually thinking about how to actually make these attestations. But no one's going to do anything while it's a draft. Nobody's going to do anything while it's a draft because there are so many drafts. And, spending a whole bunch of time and attention on a draft and having the draft just expire into nothing is a waste of everyone's time. So it actually needs a kick. But the Cider Ops working group has this, we're not a protocol working group problem. And so it's languished for 3 years without any major change. And if I sound frustrated, it's because I am.
Okay. Thank you so much, Geoff, for your always candid commentary on things. I mean, how good it is to start a RPKI week with a candid criticism on RPKI. But we are trying to encourage operators to create ROAs. Meanwhile, we pick your brain power to solve the distribution issue within the RPKI. We're going to solve it, hopefully.
There are many moving parts, and getting the the certification infrastructure, the digital signature infrastructure, having operators be aware of how to manage keys, having, these issues out there and working is a really big step, right? So the work with ROAs is not wasted work. We're going to be using them no matter what, right? I'm just suggesting there's a different way of dealing them around the internet rather than, knocking on everyone's door. Hi, have you got a new ROA for me today? We could do this better. You can deliver it to my door. Thank you very much. But, that work is not wasted work. It is good work and it needs to happen. And this initiative with Manners needs to happen. We've got a lot of work to do, and motivating folk as to why is really helpful. But everything in the garden is not rosy. It's not finished yet. And we shouldn't congratulate ourselves that, it's a job well done and all we've got to do is deployment. There is still work to do, and it's good work to do.
Absolutely. Thank you so much for that. And I'm a firm believer on one thing. In order to resolve a problem, you have to first realize that there is a problem. So I think we're going through that realization phase that there is a problem, and it's all moving parts together. We will fix that problem, folks. Don't worry. We still have Geoff. We still have DGM. We have Geoff Snyder around and other folks who are enthusiastic enough to solve these problems. So just
can I just do one small ad here?
Yeah.
I just in the last couple of days have done a Herculean effort, and if you ever suffer from insomnia and you really need to fall asleep at night, the APNIC blog is just carrying a massive piece of work on all of this background to how BGP security, how the story evolved, and what are the strengths and weaknesses of the various approaches. And that survey, part 1, is out as we record this today. Part 2 will be out through the week on Manners, giving something you can read at leisure and fall asleep by anytime you like, because no apologies, it's a big piece of work. But I think it's useful for this particular discussion.
It is really a good piece. I read it and I shared it, and trust me, it has been shared so many times and people are loving it. So thank you so much, and we are all looking forward to the part 2. And hopefully a part 2 conversation in a couple of weeks or a couple of months' time, when we can have some more discussion on resolving the distribution part of the origin validation certificates. So thank you so much. Till then, hopefully we will be in touch again.